Hi guys, welcome to our channel Helm of Science. I am Shoran and I will be discussing physics with you guys. So the first chapter I will be discussing about is force and pressure. It's one of the most important chapters of class 8, so let's get started. So when I say that I have applied a force, what do you mean? Let's take an instance. I'm pulling a bucket of water from the well. So what am I actually doing? I'm actually applying force and pulling the bucket. If I push one of my friends, so what am I doing? I'm actually applying force. So force can be described in simple terms like with as a push or a pull. It can also be described as a cause which changes the state of rest or motion of an object. If I place a football on the ground and I kick it hard, so what am I doing? I'm applying force. So what does it do? The previously in a state of rest comes into a state of motion. In a football match, when the goalkeeper catches the ball which was in a state of motion comes to rest. So by applying force, we can change the state of rest or motion of an object. Force can also change the direction of motion of an object. Let's say in cricket, when the batsman hits the ball is in motion and is in one direction, but when it hits the bat, it goes into another direction. So it changes the direction of motion of an object. With force, it can also change the force can also change the shape and size of an object. Let's say an elastic band. I'm pulling it. So I'm pulling it so it stretches. So what does it do? It changes the shape and size of the rubber band. So now we'll come to the types of force. There are two types of force. One is contact force and the other one is non-contact force. Under contact force we have muscular force and frictional force. Muscular force is the force which we can apply with the help of our muscles. For example, when we pull a bucket of water. Now, frictional force is a type of contact force. Now, let's say we have placed a box on the floor and we have applied the force in this direction. So the box will move in in the direction of force only, but the frictional force or the force of friction comes into play and it is in the direction opposite to the direction of force, applied force. So the friction force is a contact force which comes into play due to the contact between the box, surface of the box and the floor. So these are the two types of contact forces. Now we'll move on to the non-contact forces. There are three non-contact force. One is the gravitational force, the other is the magnetic force, and the last one is electrostatic force. Now the gravitational force, the force with which the earth pulls everything towards its center. It is also the reason due to which all the planets revolve around the sun because of the gravitational pull of the sun. It is a non-contact force and it is always attractive in nature. Now the second one is magnetic force. Like if I place a magnet near iron pins, it will attract the iron pins towards itself. So it is again a non-contact force which is always attractive in nature. Now the third one is electrostatic force. We have often seen when we comb our hair and we place the comb near pieces of paper, it attracts the pieces of paper towards itself. It is due to the charges which are the charges which are getting created on the comb and it attracts the paper. This is a non-contact force and it can either be attractive or repulsive. The other two were always attractive, but this can be either attractive or repulsive. One interesting fact relating to the gravitational force is that the weight of a person on the earth is different to that of the moon. Now, the masses of both the same person on the earth and the moon are same because mass is the amount of matter contained in the body. It's same. However, weight is the force with which it is pulled to the center of the earth. So weight is a product of mass into the force of gravity. Now, the weight is different of the same person on the moon and on the earth because the gravitational force of the moon is around 1 by 6 times that of the earth. So, the weight of the person on the moon is 1 by 6 times that of the on the earth. Now, the SI unit of force is Newton. It is expressed in terms of Newton. Now, now imagine a scenario where a block is placed on a floor and it is free to move. So if we apply the force in this direction, the motion of the block will also be in the direction of the force. So it's free to move, and the direction in which we apply force, it is moving in that direction. So this motion is known as translatory motion. Translatory motion. Now, however, if this is fixed, there is a fixed point. Okay, I'm drawing it again. If the block is not free to move now, if it is fixed, let's say now it is fixed, it's not able to move. So if we apply force over here, what will it do? It will not move in that direction, rather it will rotate about the fixed point or the pivot. We can also say it as a pivot. So it will not be in the direction of motion of the force. This is known as the moment of force, or simply it is known as torque. It is known as moment of force or torque. Now take an example. We have, let's say we have a door, and these are the hinges of the door. We all know these are the hinges of the door, and we have a door. So if we apply force in this direction, the door will open in an anti-clockwise motion. Anti-clockwise motion. However, if we apply force from the other direction, the motion of the door will be clockwise. So, moment of force is responsible for clockwise or anti-clockwise motion of a body. So, now the moment of force or torque depends on two factors. So, these the two factors on which the moment of force or torque depends are the factors on which torque depends is the perpendicular distance between the point of application of force and the fixed point, and the second factor is the magnitude of force. So let's understand it with an example. Let's say this is the door, this is the knob, these are the hinges. So these two hinges are the fixed points. These two are the fixed points. So if we apply force over here, so the distance, for the perpendicular distance d, which we can denote as d, the torque depends on d. The torque depends on the d, which is the perpendicular distance, and the magnitude of force, which is F. So we know that SI unit of force is Newton, and distance is meters, and SI unit of distance is meters. So what will be the SI unit of force? What will be the SI unit of torque? Torque can be expressed as torque or moment of force can be mathematically expressed as the product of force into distance, the perpendicular distance and the magnitude of force. So the SI unit will be the SI unit of force is Newton and distance is meters. So SI unit of torque is Newton meter. It is expressed in terms of Newton meters. Now we will come to the applications of torque. Now what are the applications of torque? The first application that comes to the mind, and I have already described it with an example, is a door. now these are the hinges. Now if we locate the knob here, so the perpendicular distance will be more, but however if the knob is located midway, the knob is now located midway, so the perpendicular distance d decreases, and we know that torque is a product of the magnitude of force and the distance. So if distance decreases, the torque will also decrease. So for opening the door, we have to apply much more force than if we place the knob at the extreme end. So this is one example application of torque. The second application is that we have often seen the spanners which are used for tightening the nuts and bolts. The spanners look like this and they are used to tighten the bolt. Now the axle of the spanner is, the arms of the spanner is made longer so that the distance increases and we can open that or tighten the nuts and bolts by applying less force. If it is made half of it, we have to apply more force, double the force we have to apply. So this is another example. Third application is that the pedals are made longer with respect to the axle. If the pedals are made smaller, we have to apply more force for turning the wheels. As the pedals are longer, we have to apply less force. So these are more or less some of the applications of force. Now we will move on to a numerical to understand the concept better. So the first numerical says that the distance of application of force from the pivot is 2 meters. The magnitude of force is 70 newtons. Find the moment of force. Okay. So I'll read it again. The distance of application of force from the pivot is 2 meters. The magnitude of force is 70 newtons. Find the moment of force. So for this sum, I'll first write down the data which is given in the problem. Given are the perpendicular distance d, perpendicular distance d, which is 2 meters, and the magnitude of force which is expressed as F equals to 70 newtons. So the torque or moment of force will be the product of D and F. So what is D? D is 2 meters and force is 70 newtons. We will put this in the equation and we will easily find the torque. So 2 into 70, which will be equal to 140, and the unit of torque is Newton meters. If we forget to mention the unit, it will be wrong. So the unit of torque is 140 Newton meters. So the answer is 140 Newton meters. Now the second numerical says that numerical 2 says that a torque of 30 Newton meter is created when a force of 2 newtons is applied. What will be the perpendicular distance between pivot and point of application of force? Now What are the two things which are given in the problem? These are the torque, which is 30 Newton, and the force, which is 2 Newton. So first let's write down which are the things which are given. So torque T is 30 Newton meter, and the force, which is F, it is 2 newtons. So we know that torque is a product of force and distance, which is the perpendicular distance between the point of application force and the pivot. So if we place the values of these two in the equation, we can easily find out D. So let's do that. So T is 30, F is 2 cross D. So D becomes 15. D becomes 15 and the unit of D will be meters. Answer will be 15 meters. The direction, the distance between the point of application of force and the pivot is 15 meters. So it's easy. The numericals are quite easy, and I hope the concept of torque is clear. So guys, if you found the video useful, please like the video, subscribe our channel for more videos, and share our channel among your friends and family members. So bye, see you in the next video.